Hello, I'm Glenn Howard from Cromer Industries. Today I'd like to talk about coupling drift, which is a phenomenon that can occur when you join two plain end pieces of water main with a reducing coupling, although it could sometimes happen with transition couplings, and I'd like to describe some of the risks that are involved with this phenomenon. Now let's take a minute and think about the forces that are acting on a pipe joint. Now, one of the forces is the tendency of the pipes to pull apart under the pressure that's in the line. So if you have two pieces of pipe joined together like this with a coupling, there is a tendency for them to push apart under pressure. That's not what we're talking about when we talk about with coupling drift. This sort of pull-out force is something that you should probably deal with thrust blocks further down the line. It changes in directions, or by the use of mechanical restraints. So let's assume for today's discussion that we're not talking about pull-out forces, but rather that the pipes are fixed in the ground. Rather, what we're concerned about is the tendency of perhaps the pipe coupling to move or slide or drift down the pipe and potentially uncover the gap and then commence the leaking. So let's go ahead and take a look at an example of where this can be a problem, this possibility of drift of a coupling. What you're looking at now is a schematic of a 6-inch joined to a piece of 4-inch pipe with a reducing coupling joining the two together. So the dark blue is the pipes, of course, and the lighter blue is to show the pressurized water within the body of the coupling. Now, if you think about the thrusts that are pushing from the 6-inch against the 4-inch, they're not quite balanced. And I hope you can see from this sketch that this tendency will cause the coupling to try and push in the direction of the red arrows, and actually could potentially push right off the 6-inch pipe, and therefore you would have a leak. Now, what's stopping this from happening under normal conditions? Well, it depends, but you're going to get some resistance to movement from friction between the gasket and the pipe, of course. You're going to get some resistance from the overburden of the soil, like the friction against the soil on the outside of the coupling. And I guess under a surge condition, you might think about perhaps a little bit of inertia resisting the movement. But in general, over time, you can see, I think, that there's a risk the thing is going to creep off the pipe, especially if you have lots of pressure surges in your system. Now, just to give you an example of how big a problem this could potentially be, in this next slide here, what I've done is work out the math to show you what the unbalanced force actually comes out with. Now, I'm not going to bore you with the details of the math. I've put it there. If you want to take a look at it more closely, just pause this video and check my figures. But you'll see that I used 100 psi as a working pressure just for easy mathematics. So the thrust pushing the coupling to the right is pi r squared, the area of the pipe, times the pressure, which is 100 psi, and that's 2,800 pounds. The area, the pressure resisting that thrust is pi r squared times the pressure, which is 1,250 pounds on the right side. That's an unbalanced force of about 1,500 pounds. That's a formidable force. That's a very strong force trying to push that coupling off. So I hope you can see that in a reducing coupling, this risk of drift is not an insignificant one. Well, in the next video, I'm going to talk about some of the ways to reduce the risk of this problem. Thanks for watching. I hope you enjoyed it, and if you have any questions, as always, please feel free to contact me. Thank you.